Hello, we are here for one more lesson of this TFlexCam training course, and the topic for today will be the turning machining. These turning operations will be split in two lessons. We will make this part one video considering a couple of types, and we will talk about the finishing turning, roughing turning, threading and drilling. We will leave for the next video the second part of the turning operations. With that purpose, I've opened one of the drawings that we have on the standard installation, and I will use this 2D drawing to create a couple of examples. So the turning operations, again, this is a 2D machining type and uses a lot the paths. So to start, I will create a couple of paths that I will use as base to create programs. So let us create one or two different types of construct lines. And now path. So path, okay, perfect. Now CMC, the first type of turning, so turning operation. I have this one, it's a finishing operation, and it's very easy. So finishing, I will use this tool that I have already created. I will choose my path, that is this one I've created on the 2D side, and I will change a couple of parameters. So feed rates, rapid work feed rates in both axes. This coefficient is it uses a formula from these two feed rates. So I think it was important for you to see our theoretical side, to see what this can do. It's not very important for understanding the options at this moment. Allowance, this is the excess or not material that we leave considering the original contour. So activating cooler or not, spindle direction and RPMs. We can activate this option here that open a window with the different elements of the contour, and for each element we can define these feed rates, spindles and so on. I will leave this behind, it's not very important now. Radius correction you already know from the wire EDM program, it's the same principle. The approximation the same, considering circular interpolation and the precision in those cases, and also additional parameters, you know these already from the other program. So just saying, okay, it has a mistake, but it's not correct. So I've calculated one toolpath that I will simulate now to see if it is okay or not. So play, and it's on the wrong direction. So I simply will open it and additional parameters. So counter contour, calculate it again, and do a simulation. And hopefully now I will have it on the correct direction. Okay, perfect. So first, in terms of the finishing, it is done. So now roughing operations. For the roughing, I have also the same principle, which is I need to have paths to be a base for the operation. So I have already this for the finishing that I will use, and I will create a new one for the finishing operation. And this that I've just created, it's used for because of the stock that the system will consider. So CNC, turning and roughing operations. I have three types. The first one, the allowance removal with cut through or with cut-off cutter. So let's consider this. I will open the exact same cutter that I had for the other one. Okay, and the tool paths, the part contour and then the stock contour. Okay, already something done in here. Feed rates, you know this already, it's not very difficult. Pass parameters, this has only one parameter regarding the auto or by value. And this parameter controls the offset of the first and the last passes from the boundary of the domain of machining. And by default, if it is in auto, the system calculates automatically considering the radius of the tip of the cutter. So I will leave this auto. It's not very important for the concept also. Then the turning direction, we can consider we can make the direction of the passes along X or Z, and besides from the direction of the turning from left to right or right to left, downwards or upwards. So it's a matter of changing what we want. So stock type, we can do this in number of passes, which is done in here, or by value. So if I say, for example, every 2 mil, and finally approximation, it's the same as before. So just say OK, and we have a different type of program like this one that we can simulate very easy. Okay, and that's it. So in this particular case, nothing much more to do. Okay, and next type of program, still in roughing. Now the roughing, but as a pass cutter. It's pretty similar. So part contour, stock contour. I will define my cutter again with the tool. Then we have feed rates, coefficient, the allowance, I will say 0 in this particular case. Cooler, spindles, direction. So under travel and the over travel, these are the parameters that from the beginning behind, and when the cutter goes out, these are the values. If I say, for example, 2 in here and 5 in here, so that you can see the difference. And the angle, in this particular case 45, can be other angle. I will calculate it so you can see what it does. If I edit again, so through pass, this is when it's enabled, the pass of the tool is increased by a value. For example, if I say 1, in this particular case it will decrease from the contour, okay, like this. We can, let's take it out, ignore pockets. When we have this kind of grooves, we can ignore them automatically. I've done it with my contour, but we can do this more or less automatic. Turning direction, okay, in which X we want to do the turning. Stock removal, let us say again by value and 2 mil. And besides this, we have the possibility to add one finishing to pass, just saying on. We can define the feed rates in the spindle for that particular pass, say which allowance, and we can define also this pull out that specifies the distance from the part before the execution of the contour. So I can say 3. I can insert an information to stop, and I can revert the direction. Let us calculate this now. And okay, done. But you see the final pass, it is wrong, and we should see my finished pass. So revert the direction, and now sim OK, and I can do a simulation. Let us see if it is correct now. And final pass. Perfect. Then we have another type of roughing operation, and I will create one new toolpath. For example, first I will create, let us say, a couple of lines. Okay. And a path from here to here to here only. And this last roughing kind of operation will allow it to, for example, on an inner corner, to make a couple of passes there. I will use only this exterior corner. It was not the obvious choice, but as example, I think it's okay. So turning, not this one. So corner turning. I will choose my toolpath. Not sure because it's behind the other one. Let's try to choose it again. Okay, I'm choosing the other one, which I don't want. But okay, as an example, it's clear enough. So let us try to use the same cutter, because independently of being this contour or the other, the idea here is choosing a contour. Okay. So again, I will say 0 in this particular case. The under travel and the over travel. So you see the over travel 4 mil. This is half 2 mil in here, and the angle we can give, for example, 30 degrees. And we have also these operations preform and in both X and Y that may allow you to say which are the passes. And we can begin with first or last also. I'm doing the first. So stock removal parameters, I can say by value. And if I say by value, I can say synchronously, which with this we remove material from one side to the other or not, so it's not very important. So just saying okay, and something like this appears. Okay, I think it's also easy to understand. So now we have other types of machining. So finishing, it is done. We have this pocket turning that we will see later, and this groove turning also for the next lesson. So now I would like to show you the threading. And threading, it can be done in several ways. Just 1 second. I'm also changing my papers so that I don't forget any detail. Threading, it can be used in several ways, as I was mentioning. So with a cutter, or with a tap, or this special one, which is basically the same. So I will use, this is a little crowded, I will use below I will create a path. So path, and simply let us simulate a thread in this area here. And now CNC turning with a cutter. Let us open this file with this tool, choosing this path, and parameters, okay, thread step, thread depth, and number of passes. So number of passes, I will say 5. Number of entries in thread, the over travel I will say 2, the under travel also 2, and the offset on diameter, which is the distance from the external diameter of the thread to the initial point, I can say also 5. Let us say what it does, okay, and has done something like this. Let us do a machine simulation, okay, and simply, okay, good. Now we can make, instead of by a thread, we can do a thread cutting, and this is used, for example, for inner thread, okay? And this is done, for example, in this hole. Again, we need to create one path from this point, for example, until this point. Done, so CNC, turning, thread cutting. I will use the same tool, oh sorry, in this particular case it cannot be, because it should be a tap. So let us choose a drill, and let's open again, not going, oh sorry. So let us abort this, let us create a new one from scratch, because it's not or the toolpath, it's this one, the tool file, I will choose one of the defined toolpaths. For some reason I am having problems. Okay, let us open the editor. Okay, I was trying to insist in this, but okay, this is a threading. We can use this threading cutter, not this one again. We can use this, which one? No, the drill tool, we can use it. We can have parameters on this, define the diameters and the corners and so on. For this particular case, sorry, to list, save as, I will call it AA. Okay, close it. And regarding the turning, because in fact it's a definition of the correct tool, and for the program it will consider the tool you have, so it's not very important. So tap, and then we can open this tool here, Okay, it's a drill tool, but in fact, if it was a tap, so it will do the same work. So simply in here, we define the under travel and the over travel. So it's quite simple. So if we say 2 mil in here, so it will start a little before, and simply, if we do a simulation, what it does, it's something like this. So you see, even the diameter, it is wrong because it's much bigger than the hole we have, but I'm not focusing on the diameters, just the operation itself. Finally, in terms of these types of machining, we have the drilling operations. So we have axial drilling and the special one. This has a couple of more parameters. It's not very important now. Let us consider how to do the drilling in terms of this turning operation. So drilling, we need a tool path. I have already a drill here. I don't know which is the diameter. I will not consider it important again. So the path, it's this one. We have these parameters you know already: feed rate, spindles, coolers, and so on. Type of cycle, a simple drill or a deep drill. So if it is a drill, safety plan height, where we can define the height of the safety height outside of the part. And this is the parameters when it makes a transition of the tool. This is the height where the feed rate, the working feed rate, is turned on. So I should do it a little above my part. Offset correction, this is similar to what we've seen in other types of programs. So simply do it, and if we simulate it, okay, just done. Okay, let's simulate it again. So play it. Okay. If I go in here and say not a drill but a deep drill, I have a couple of more parameters, which are, again, you know, these are equal to the other. This is the increment, they call it usually the peck drill. This is a coefficient that it can have an option on the post processor, okay. And this value for the pull out, it's the value of the pull out at each step of the deep drilling. So let us say 3 mil, and let us simulate what it does. Play. So okay, it will do a peck drill on this. So in terms of turning, for this more or less simple tool path, I think we've covered all the options. For the next lesson, we will see the other type of operations we have in terms of turning. I hope these examples were clear enough to show you how to do turning operations. Anyway, in case of need, okay, send us an information. We'll try to help you according to your needs.